I am Mark, virtual teacher instructor at Egnatia Career College. Today we'll teach fittings, valves and devices. This is video number 2. Fittings. Fittings have wide range of uses in various systems. The 360-degree circle and the geometric right triangle provide the basis for describing the degree of fitting. The most common offsets used in the plumbing industry are 90-degree, 1/4 of a circle, 45-degree, 1/8 of a circle, and 22.5-degree, 1/16 of a circle. A 22.5-degree fitting is used for DWV systems, and 90-degree and 45-degree fittings are manufactured for most other piping systems. The 45-degree fittings are not used in flexible tubing systems, because flexible tubing allows offsets that are created without fittings. Each offset fitting is also called an elbow. The degree of a fitting is usually referred to when ordering fittings. However, DWV cast iron fittings are ordered by the fraction of a circle the fitting represents. A cast iron 90-degree fitting is ordered as a 1/4 band, a 45-degree fitting as an 1/8 band, and a 22.5-degree fitting as a 1/16. Various fitting designs. Water distribution fittings are more compact than DWV fittings because water flows through the piping with pressure. A DWV system drains by gravity and has unique fitting characteristics that limit the flow restrictions within a piping system. Fittings are classified by their designs and are named based on their material type and unique characteristics. Fittings are available with one of two basic connections. Some can either receive pipe, i.e., have a hub, or be inserted into a hub or socket of a pipe end. Others, such as no-hub cast iron and HCI fittings, are connected with a specially designed clamp. A street fitting has one end that receives pipe and the other end with the same kind of connection as the pipe. The sizes of the smallest plastic DWV and smallest cast iron pipe and fittings are 1.25 and 1.5, respectively. Offsets. The purpose of all offset fittings is to change the direction of piping. Several variations of 90-degree offsets are designed for specific uses. Pressure systems, such as water and gas, use a short design pattern, and DWV systems use a longer radius design pattern. Two 45 degrees fittings can be joined to create a 90-degree offset. 22.5 fitting, which is common in a DWV system. Two 22.5 fittings can be joined to create a 45-degree offset. A swing joint is a combination of two fittings that create an offset in a piping system. Some difficult piping installations often require a degree of offset that cannot be achieved with the use of certain fittings. A common swing joint configuration uses 90-degree and 45-degree fittings to offset around an obstruction or to create a compact rolling offset. T's. A fitting with 3 connections used for pressure systems is known as a T. DWV systems use a T design with a different flow pattern than a pressure T. The openings of a T are identified as either run or branch for sizing and ordering purposes. Run openings are those in the direction of flow through a T, and a branch is perpendicular to the run. When ordering a T, the largest opening is stated first, then the size of the run, and finally the size of the branch. One exception is the bullhead T, in which the branch is larger than the run. In this case, the branch size is stated before the run size and the term bullhead T is included. If all 3 sides are the same size, then only that size is used to order the T. When both sides of the run are the same size, the single run size and the branch size are used. The same set of dimensions is used to order a T, regardless of the material type. Couplings. A coupling, also known as a sleeve, connects 2 equal-size pipe ends to form one continuous pipe. Except for SWCI pipe, every piping system uses a coupling to connect 2 pipe ends. A coupling is not available in a street design. The connecting method for a piping system dictates whether a coupling has threads or a socket or is inserted into the pipe. A coupling designed for flexible tubing is inserted into the tubing. The coupling NHCI uses is called a clamp. SWCI double hub fittings are rarely used because each pipe end has a bell to receive a plain pipe end. Some plastic pipe also has a bell on the end of each length of pipe to eliminate the need for a coupling. Reducers. A fitting that connects two different size pipes is called a reducer. A reducing coupling joins two different size pipe ends. Both sides are designed to achieve the same result as a coupling. A fitting reducer is a street fitting. The largest side is the street side, which inserts into a socket of another fitting to reduce the pipe size. A fitting reducer is often used when other reducing fittings are not available. Inserting a fitting reducer into a coupling can create a reducing coupling. A reducing T is created by inserting a fitting reducer into side 2 or side 3 of a T. Bushings. A bushing connects two different size pipes. It is similar to but more compact than a fitting reducer. A bushing is inserted into a fitting hub and receives a pipe end or street fitting. Male adapters. A fitting with external threads on one end and a socket connection on the other end is known as a male adapter. A male adapter is manufactured to iron pipe size, IPS standards. It has the same outside diameter as that of equally sized steel pipe threads, regardless of the material used to produce it. Female adapters. A fitting with internal threads on one end and a socket on the other end is a female adapter. The threaded portion of a female adapter is the opposite of a male adapter. Unions adapter. A three-piece fitting designed to provide direct access within a piping system is called a union. Unions connect inline systems to piping systems. They are used primarily in pressure systems, but can also be used in portions of DWV systems that require sewage pumps. Unions installed on equipment such as water heaters make replacement easier. Water distribution systems. Water distribution systems provide safe drinking water to our homes. This table lists the 6 materials that are discussed separately in this chapter, as well as the fitting materials used to complete a system. Water distribution fittings. Various fitting designs are used specifically in water distribution systems. The use of a brass fitting with a soldered end is determined by the connection rather than the material used. PEX. Cross-linked polyethylene (PEX) has become one of the most popular materials for water distribution systems in residential construction. Fittings and accessories used with PEX are typically made of brass, but a leading manufacturer does offer them in a new plastic material known as polysulfone (PLS). These fittings have a unique ribbed pattern on the exterior for holding once they are installed. Depending on the type of tubing installed, these fittings can be connected either by crimping or by expanding. CPVC. Chlorinated polyvinyl chloride, CPVC, is another popular choice of material for residential water distribution systems. Because most plumbing codes approve using both CPVC and PEX for water distribution systems, the choice of one over the other is typically a matter of preference. CPVC fittings are manufactured from the same materials as the piping, and connections are solvent welded, glued, with special glue. CPVC glue cannot be used with other types of plastics. After an installation is complete, a solvent welded joint must cure for about 24 hours before the system can be pressurized. Copper. 3 different grades of copper tube are used for water distribution systems, but the fittings for all 3 are the same. Copper fittings for water distribution are different from DWV systems copper fittings. Copper DWV fittings have a greater radius and a shallower socket because a DWV system drains by gravity compared to water distribution systems in which pressure forces the water to flow. Copper fittings are joined to copper tube by soldering or brazing. For soldering, the tube ends are sanded clean, and the fittings are cleaned with a wire brush. The tube end and fitting sockets are thinly coated with a specially formulated paste, called flux, and assembled. Heat is then applied to the fitting, which melts the flux, and a lead-free filler material, known as solder, is used to weld the fitting to the tube. The soldering process increases labor costs on a job site, which is one of the main reasons that PEX and CPVC have become popular for residential construction. Many fittings used in copper systems are made of brass, but are soldered like copper fittings. Polyethylene. Polyethylene PE tubing uses nylon and galvanized or brass fittings. PE fittings have a unique rib design, which is compatible only with PE tubing. Galvanized and brass. Galvanized pipe is no longer used for entire water distribution systems, but galvanized fittings and nipples are still installed. PVC. PVC can be used only for the exterior portion of a residential water distribution system. Pressure rating and fitting designs for PVC are different from those for DWV. The flow radius of the fittings for PVC is more compact, and the fitting socket is deeper, so the solvent welded joint can be exposed to higher pressure. CPVC male and female adapters are available with both brass and plastic threads, but PVC adapters are made only with plastic threads. A PVC female adapter should not be screwed onto a metal male adapter. The expansion and contraction of piping systems could cause the plastic female adapter to crack and leak. Metal to plastic connections should be performed only with plastic male adapters and metal female adapters. The size of pressure PVC in residential applications is usually 3/4. Drainage waste and vent systems. Drainage waste and vent, DWV, represents the combined drainage and vent systems. This table lists common fittings installed in DWV systems and their approved flow positions based on plumbing codes. Combo. Combo is the trade name for a three-sided fitting that creates a long radius 90-degree branch, side inlet, that is perpendicular to the run. Sanitary T. A sanitary T is a compact fitting with three connections that is used in drainage and vent systems. Sanitary Cross. A sanitary cross has four connections, two of which are branches, and has the same flow pattern as a sanitary T. It is used to connect fixtures that are located side by side and back to back. Twin elbow. A twin elbow has the same flow pattern as a sanitary T, sanitary cross, and standard 90-degree elbow. A cast iron twin elbow is ordered as a double quarter bend. It is called a twin elbow because two 90-degree fittings are made to connect back-to-back fixtures in a confined space. This three-connection fitting is limited to connecting low-volume fixtures, such as sinks, that share a common drain pipe. Test T. A test T cannot receive discharge from a drain. It is used in a drainage system to provide access for cleaning and is often referred to as a cleanout T. It also serves as a place to install testing accessories for the required testing and inspection of a DWV system. A test T has three connections, one with female threads, and with the side connection being 90-degree from the flow. Cleanout. Cleanouts are installed throughout DWV systems to provide access into the piping to clear obstructions. A female adapter and a threaded plug, often called a cleanout cover, are used together to create a single fitting. Codes dictate the location and size of cleanouts. Plastic DWV cleanouts are installed over piping, and a street-style version is inserted into a fitting hub. Closet bend. The closet bend, a reducing 90-degree fitting, is the last fitting of a drainage system serving a toilet, also known as a water closet. Codes dictate that downstream pipe and fittings must be the same size or larger than upstream pipe and fittings. A code exception allows the installation of a closet bend fitting, which is a standard radius fitting, with the flow from vertical to horizontal. The 4-inch side of the closet bend can be installed only vertically, with the 3-inch piping installed horizontally. A plastic street version is available with a 4-inch street side and a 3-inch side with a hub. Heel inlet 90-degree. A heel inlet 90-degree is a specialty DWV fitting that a plumber often refers to as a heel outlet fitting. It is a DWV 90-degree with a branch located at the heel of the bend that can be used only in specific locations. Closet flange. The flange that connects the toilet, water closet, to the drainage system is called a closet flange. Closet flanges are often made from PVC, ABS, or cast iron. Plastic drainage materials have compatible flanges that are solvent welded, glued, to the piping system. P-trap. Every fixture must be served with a protective water seal to prevent harmful sewer gas from entering an occupied space. A P-trap gets its name from its similarity to the letter P. It receives the outlet flow of water from all residential fixtures except a toilet, which has an integral trap. P-traps are available in various styles, including one-piece and two-piece designs. Trap adapter. A slip-joint P-trap is tubular and has a smaller outside diameter at the connecting DWV pipe. The fitting that connects tubular sizes to DWV pipe sizes is called a trap adapter. A trap adapter resembles a male adapter, but has a slip-joint nut and washer. It is typically installed at the fixture installation phase of a project. It is connected to plastic DWV piping systems with a solvent welding process, gluing, and must be made of the same material as the plastic DWV pipe. PVC. Polyvinyl chloride (PVC) is one of the most widely used products for DWV installation in the residential plumbing industry. PVC fittings are manufactured from the same material as the pipe and are sealed with a solvent welding process, glue. ABS. Acrylonitrile butadiene styrene (ABS) pipe is commonly used. ABS is black in color and easily distinguished from PVC, which is white. Cast iron. It is primarily used for underground installations. Cast iron fittings are more expensive than plastic products and often take longer to install. Cast iron is used more frequently in the commercial plumbing industry, but a residential plumber must have knowledge of cast iron fittings and basic installation. Corrugated stainless steel tubing fittings. Corrugated stainless steel tubing, CSST, a flexible piping product, is used in gas distribution systems. Isolation valves. Code requires every residential dwelling to have at least one isolation valve. Isolation valves are made in various types and sizes. Most codes dictate that the minimum size for a residential water service is 3/4 inches. Table provides a list of common isolation valves that will be explained individually. Valves are full port and restricted port. To indicate the flow direction, all directional valves and devices are marked with either an arrow or the designated in or out connections of the valve or device. Some valves and devices must be installed only in certain positions, such as vertical or horizontal, but others can be installed in any position. Ball valve. A ball valve has an internal ball with a hole in its center that creates a flow passageway through the valve and isolates flow when the ball is rotated 90 degrees from the flow direction. Some ball valves have a T-handle, but the most common ones have a lever handle. A vertical stem protrudes from the valve body of the internal ball. The lever handle is secured to the stem with a tightening nut. The lever handle design, which only requires a 90 degrees rotation to close the valve, classifies a ball valve as a quarter-turn isolation valve. Gate valve. A gate valve has a metal gate disc that slides vertically to open and close the valve. A wheel handle fixed to a stem raises and lowers the internal gate when it is turned. The handle is turned counterclockwise to open the valve and clockwise to close it. The two basic types of gate valves are the rising stem type and the non-rising stem type. Stop. A stop is a directional flow isolation valve that uses a rubber washer to stop the flow of water. Various designs exist to serve as isolation valves either for an entire water distribution system or for an individual fixture. The popular ball valve has replaced the stop as the main isolation valve for an entire house. The stop has a wheel handle secured to one end of the stem with a screw and a rubber washer at the opposite end of the stem. It is a restrictive port valve, which is one reason it is no longer widely used in piping systems. A stop is more popular as an individual fixture isolation valve, and is often installed to connect the water distribution system to the fixture tubing connection. Stop and waste valve. A stop and waste valve is designed like a stop to isolate an entire water distribution system, but it has a draining feature as well. When freezing is a concern, or when a small portion of a piping system must be drained, a stop and waste valve is installed. It is a direction valve with a flow direction arrow marked on the body of the valve. It is not available as an individual fixture stop with a compression connection. A stop and waste valve cannot be installed where a backflow of non-potable water could enter the water distribution system through the drain port, while the system was not under pressure. Many kinds of valves can be installed below ground in specially designed valve boxes, but according to all codes, installing a stop and waste valve below ground is illegal. Hose outlets. Various types of hose outlet connections are used in piping systems to drain equipment and systems and to supply water. The most common hose outlets are categorized as boiler drains, hose bibs, and wall hydrants. Hose threads are different from pipe threads. Outlets have 3/4-inch male hose threads. A hose connection to a piping system can provide a primary point of entry for contaminants to pollute a water distribution system. There are strict regulations concerning the design and installation of all hose connections to a water distribution system. Back siphoning can occur if a hose connected to a water supply pipe is placed in a contaminated source, and the water system becomes depressurized. The hose can act like a drinking straw and allow backflow into the water distribution system. Boiler drain. A hose outlet connection to drain storage tanks is known as a boiler drain. Because a boiler and a water heater are protected with other approved backflow devices, most codes do not require backflow devices in boiler drains. The boiler drain has numerous uses within a system, but its most common residential application is draining. A boiler drain has a restrictive internal design feature similar to a stop that uses a rubber washer to stop the water flow. Most washing machine boxes have boiler drains. Hose bib. A hose bib, also known as a hose faucet or a silcock, allows water to flow from a pressurized piping system. Some hose bibs are similar to boiler drains and others are freeze-proof. Most hose bibs are protected with a backflow device. We are showing a common freeze-proof hose bib installed in a residence and equipped with an anti-siphon device. The freeze-proof hose bib in the other figure is illegal because it does not have an anti-siphon or backflow prevention device. Reactionary valves and devices. Many valves and devices react automatically to temperature and pressure differences or to the reversal of flow within a piping system. Safety valves and devices can regulate pressure or discharge high pressure or temperature, and many others protect potable water systems. Numerous devices are installed in piping systems, and some of their operating features are similar regardless of the manufacturer. Most safety and regulating valves and devices have a flow direction and must be installed according to the manufacturer's requirements. Safety devices are a crucial part of potable water installations. Table explains reactionary valves and devices. Pressure reducing valve. A regulating device known as a pressure reducing valve, PRV, reduces the incoming water pressure to a safe operating range. Many models are available, and residential models can be manually adjusted to accommodate a particular installation. Relief valve. A relief valve protects a piping system and equipment from extreme temperatures and pressures. All relief valves are self-operating and open and close as they react to operating conditions of a system. Many dual-use relief valves provide protection against both temperature and pressure. These valves are called TNP relief valves. Check valve. A backflow prevention device known as a check valve is installed to ensure that water flows in only one direction. Installing a single check valve is not an approved method for protecting a potable water system from contamination. Check valves are used in residential applications for hot water circulating pumps and well pumps. Swing and spring check valves are the most common for residential applications. The swing style is used for most applications, but the spring is employed more often for well pump systems. Vacuum breaker. When a water distribution system is isolated or loses pressure, a vacuum is created that can allow contaminated water to enter a potable water system. As its name implies, a vacuum breaker breaks a vacuum created in a piping system. To prevent the possibility of contamination, many forms of vacuum breakers are installed throughout a piping system. If a vacuum occurs in a piping system, air is drawn through the vacuum breaker to equalize the pressure in the piping system, so the potable water outlet does not become a point of entry for contaminants. Vacuum relief valve. A vacuum relief valve or atmospheric relief valve is installed in the cold water piping that serves a water heater. When it senses a loss of water pressure, it opens to equalize the piping system with atmospheric pressure, zero gauge pressure. During normal operating conditions, the vacuum relief valve can withstand pressure without leaking. It opens only when it detects a loss of system pressure. Various vacuum relief valves are available for use throughout a piping system. Most residential water heaters are connected at the top of the storage tank and are equipped with a factory-installed funneling tube known as a dip tube. The dip tube is inserted into the cold water inlet connection and routes the incoming cold water to the bottom of a storage tank. It also has an anti-siphon feature. The manufacturer drills a small diameter hole in the dip tube a maximum of 1 inch from the top. This breaks a vacuum if a negative situation occurs within the tank. This feature allows only the top 1 inch of hot water to flow out the storage tank and into the cold water piping system. Reduced pressure zone. A reduced pressure zone (RPZ) valve is the most reliable device for preventing backflow of contaminated water into a potable water supply system. An isolated zone is created on the downstream side of an RPZ valve. Most codes dictate that a certified technician must test and certify annually the RPZ valve for its correct operation. The test ports required for annual certification are installed at the factory on most devices. Because the annual test can require replacement of internal parts, many codes dictate that the maximum height above a floor is 36 inch to allow for servicing.